Hey class, so last time we looked at the structure of the heart and the way that it functions as a double pump and how that gets regulated. And today we're going to look at blood pressure and how that pumping is able to help control the pressure and make sure that blood gets to where it needs to be all throughout the body and the role it plays in homeostasis. All right, here we go. So if you think about liquid going through some type of pipe or tubing, if you put the same amount, the same volume of fluid through it, then the larger the diameter, the less pressure there would be, the easier it would be for that to go through. So the smaller it gets, the more pressure you create. You can also think about the type of material that's made out of. If it was something stretchy and flexible, then it might be able to get through easier and sort of push out where it needs to, whereas if it was something that was less flexible, then again that would also push back more against the fluid and create more pressure. And that's how our body is able to control the pressure throughout. And it uses that pressure to make sure that blood continues to flow all throughout the body to get where it needs to be for gas and nutrient exchange in the proper levels. And so it creates that pressure against the vessel wall. We usually measure it in the artery of the arm as you're sort of close to where it's leaving from the heart. The systolic pressure is the highest pressure. It's right as the blood is ejected from the heart. So right as that ventricular constriction happens, then that's the pressure that you create, the systolic pressure. The diastolic pressure is the lower pressure, and that's when the ventricles are relaxing, and so sort of the resting rate of blood in the body and the pressure that it will be. So the average blood pressure is 120 over 80 millimeters of mercury, and so it's always written as the systolic over the diastolic pressure. And then reminder that this is controlled by the arterioles. So that's the level where we'll be able to adjust the pressure if needed by the body is able to. So how do we measure it? We use a sphygmomanometer, a blood pressure cuff. So it's wrapped around, like I said, typically the arm. It pumps up so that there's pressure in the cuff itself, which squeezes off the artery in the arm. As you relax it, once you've relaxed enough and the pressure in the cuff itself is enough to allow the blood to flow through and those match, then you'll start to hear a sound, and that's when we have hit the systolic pressure. As we continue to let air out of the cuff, it relaxes, it's pushing on the artery, and when you hit the point where the pressure matches the diastolic pressure, then the sound goes away. And so pump it up, listening for a sound. As soon as you hear sound, you're at systolic, release until you hit diastolic pressure. If we look at normal values, so like I said, 120 over 80 is considered normal. Less than 95 over 50 is considered hypotension, too low blood pressure, and then you can start to see the levels working up into hypertension. And having too much pressure is a significant problem and a significant issue that affects many people. And so there's a lot of work that is done on approaches to make sure that we keep blood pressure at a normal level. So the pressure creates the blood flow. By having this pressure, we're able to keep a constant blood flow throughout the body. The highest pressure, again, starts at the arteries, and we know that thinking about the structure, where we have those really thick muscular walls. It'll be slowest in the capillaries, and that's because of the huge amount of surface area that we have there, and that slow blood flow and the huge surface area allows space and time for gas exchange and nutrient exchange and waste exchange. It's minimal in the veins, so after we've gone through the capillary system, there's not a lot of pressure left, but it's enough to help keep the blood flowing back towards the heart. So if we look at it on a graph where we're looking at blood pressure, we see that it's highest in the arteries and arterioles, and then it drops off as we go through the capillaries and sort of continues to decrease as we work our way through the veins back to the heart. If we think about the velocity, again, highest sort of has this huge drop in capillaries, and then actually starts to pick back up a little bit as we move through the venules and veins. And then if we're just thinking about the cross section, the surface area, we have the lowest in the arteries, huge amount in the capillaries, and then low again in the veins. As that blood is flowing back to the heart, one of the things we have to think about is it's gone all the way out to places like your toes, and it's got to make its way back up to the heart. It's sort of going against gravity now, right? And so we need to have a system that helps keep the flow going in the right direction. So the veins have valves in them, and one of the things they do is they partner with the muscular system so that as the blood is flowing back up to the heart, skeletal muscles can contract, and that will help push blood through, open the valves, allow that blood to flow through, and then once the skeletal muscles relax, then the valves can close shut again. Now the blood is not able to backflow. There are two pathways we think about. So there's the pulmonary circuit, which comes out of the right side of the heart. This is what takes blood to the lungs to allow to get rid of CO2 and to gain the oxygen, and then we'll bring it back into the heart, into the left side. And then the systemic circuit is where blood leaves the left side of the heart, the ventricle, and will go out through the aorta and the main arteries, and will supply blood to all the areas of the body. And that's where nutrients can be delivered, and then waste can be brought in to get rid of. This just shows you a diagram of all the vessels in the body for the systemic system. One thing that's interesting is sort of for everywhere you have an artery, you're also going to have a vein that runs basically the same path. So it's going to go out, it's going to hit the capillaries in that area, and then it's going to follow the same path back into the heart. There are two sort of other specialized pieces of circulation we have to think about. We talked about coronary circulation when we looked at the heart, and how important it is that the heart itself has a great blood supply because it needs lots of nutrients and gases. And so it's actually got its own separate system from the systemic and pulmonary pathways to make sure that it's always getting the blood flow that it needs to keep the heart tissue itself functioning. And then the hepatic portal system, this is where blood is returning from the digestive tract. It goes from the digestive tract to the liver, bringing amino acids and glucose-rich blood, which then the liver will process and make blood proteins, can store that glucose, and then helps purify the blood from the digestive tract before it returns to the heart and back into the system. So I hope that gives you a good overview of blood pressure and blood flow. If you have any questions, then let me know, and we'll see you back in class.